All right, we are back. Unfortunately, the previous session was not able to play. See, we didn't have sound. It was a recorded one. The speaker asked if we could explicitly add it like a recorded session. I'm sorry for this, guys, but the format of the video was DS. I had to try to convert it, and it didn't convert. So maybe later tonight I would be able to change the format. But yeah. Anyway, one of my favorite themes, one of my favorite, let's say, technologies in Azure are agents and assistants. So we have with us Kishore Kumar. He's going to deliver a session about automation and AI, unlocking AI-powered automation with Microsoft Azure AI Agent. Uh, yeah, it's a technology that gradually is taking over, and we are getting the term AI automation more and more into our lives. So, without further ado, I'm going to add Kishore in the screen, whether it is ready. Hello, Kishore.
Hi, Joseph.
How are you, my friend?
Yeah, I'm good. How are you?
I'm good. I have to say thank you so much for being here with us, and we are so grateful to have you. We can't wait for your session, to tell you the truth. I'm going to add now your screen.
Okay.
Do you feel ready to start?
Yeah,
Uh,
good.
okay,
Yeah.
so I will be on the background. Whatever you need, please write me in the chat. Everyone, Kishore is with us. The stage is yours, my friend.
Okay. So I'll share my screen. I hope it's visible. Okay. So I'll go ahead and so myself, Kishore, like as Joseph introduced me. So today I'll be talking on this topic called as unlocking AI-powered automation with Azure AI Agent Service. So AI agent being a buzzword like for a long time right now, and I think like this should give you all a scope to actually start your our venture into AI agents right now. So, okay, I would like to welcome you all. And what does AI powered automation actually mean? So, it's nothing but like artificial intelligence here is we're utilizing AI to make things happen automatically without you or any of us having to do anything manually. So today we will be like showing you how Azure or the Microsoft Cloud Platform helps us in using Azure AI Agent to create a agentic AI workflow. So yeah, I'll move ahead. So this is our agenda today. So first we'll explain what AI agents really are. We'll skip the confusing jargon and give you a clear definition. Then we'll take a quick look at how AI agents uh, got to where they are today. And next, we'll introduce you to Azure AI Foundry, which is a toolbox full of everything that you need to actually build AI agents. Then we will discuss Azure AI Agent in detail. And finally, we will go into a demo where we'll explore about Microsoft Azure AI Agent as well as multi-agent system using AutoGen. Okay. Yeah. So, what are AI agents? So, let's start with it. So, what are AI agents? So, AI agents are software entities that act autonomously to achieve specific goals. So, like breaking that down, software entity just means a piece of computer code. Okay, so they act autonomously means it can do things on its own and without need of a constant interaction between you and the system or the software that's under I mean, that's under the concept. So, okay. So, so they are acting towards a specific goal, right? So it means actually a purpose. So it's not just randomly doing things. So it's trying to achieve something here. So it's working towards a specific goal. So that's what AI agents are. So imagine, let's just we'll imagine like we have a to-do list. An AI agent is like a super efficient assistant that will get or check every to list that you wanna like finish it off. So we will look into the agent's timeline. So we all know like of Clippy, like we must be aware like if you are part of like a previous generation, as in like in later part of like 1990s or like around that period, like you should have been aware of Microsoft Office 1997. So if you had used that, you should have definitely seen that guy Clippy. So who was Clippy? So he can be termed as the most uh, first agent that came into picture. He was very very early and not so great actually. Like in the previous years, like Clippy used to be more of hindrance rather than an enabler to actually help the users, the Microsoft users. So after Clippy, we went into Siri, and then we went into Amazon Alexa, Google Assistant, and also we went into autonomous AI agents. So right now in the future, we are looking towards an agentic AI platform. So moving towards AI agents. So let's go in deeper, like what AI agents are. So as I already iterated, like they are just software entities that act autonomously towards a specific goal. So we know what acting or what doing things autonomously mean. And but it's also important for us to remember that they are not completely independent. They still needs to be programmed and trained. So that manual intervention is required to actually create these agents. And thinking of AI agents as interns, so some interns may need some help to do a specific task, and some interns might be like an overachiever who doesn't actually need any offer help, and he would do things by himself. So AI agents, more or less, they are like interns. And moving forward, like we also must be aware of what are the platforms or what are the processes where we can actually introduce AI agents into. So some of them are chatbots, recommendation systems, automation bots, and personal assistants. So we all know about like chatbots. So ChatGPT, so it's almost like a chatbot, and recommendation system. So we all must have like used Netflix. So we have a recommendation system there. So automation bots as well as like personal assistants. So yeah, that's how it goes. And going into LLM agents. So we saw about like what an AI agent is. So it's like autonomous entities which act towards a specific goal. So now let's go into LLM agent. So what LLM agent does? So we all are aware about large language models. So if you have been like in watching our series of sessions in Azure AI Connect, you must be aware of what an LLM is. So I'll also give you a brief introduction. So LLM are these large language NLP models which have this capability of reasoning, decision making, as well as to execute a task. So LLMs act as this brain or engines that actually fuel the impressive AI application that we are seeing today. And even when it comes to LLM agents, they are the engine that sits at the back of the agent. So LLM agents use these LLMs to do things, and some of the examples which these LLM agents can be utilized in are like they can act in the answer questions, like they can provide informative and helpful responses to your questions. They can be used to summarize documents. They can be used to generate content and code, and they also automate workflows. So basically, LLM agents can do anything that involves understanding and generating text. So yeah. Okay, we know what an AI agent is, what LLM agent is. So we'll further break down what a AI agent is. So we can separate a large language model into these three specific elements. So they have access to tools, they have knowledge, and they also have the LLM capability. So all these three components act towards creating an LLM agent. And we saw what LLM is. So let's go into agentic AI. So I think you must all have heard this word agentic AI a lot. It has been like in my LinkedIn page as well. So we'll level up again and we'll talk about like what agentic AI is actually. So agentic AI are AI agents that can plan, adapt, and take multi-step actions without a manual intervention that is required. And agentic AI is all about agents that cannot just act to a situation, but actually plan and adapt to achieve a specific goal here. And that's pretty interesting, right? And this is where things get really interesting. So these agents are just not following instructions; they are making their own decisions without any of us like going and doing an intervention. and we could use this simple or like a good analogy to actually understand what LLM agent is and what agentic AI is. So let's take Google Maps. We must all have used Google Maps, and LLM agents are like this Google Maps. They have a destination or they have a specific goal. So let's take an example. Like I'm going into Google Map and I'm putting a destination and I want to go there. So I just put a destination and I click on like start, and it gives me the route to reach that destination. So it's just like I give it information, it gives me an output. So that's all. But agentic AI, so what it actually does. So let's take a self-driving car. So self-driving car doesn't just focus on the destination. It also needs to be aware of the surroundings. It needs to be aware of the vehicles that is traveling by needs to be aware of the signal. So there's a lot of sensors and a lot of components that dynamically work together to achieve this, like a self-driving car to reach from its, starting point to the destination. So that's how agentic AI is. So they have these components called as like memory, reasoning, and multi-step workflows, tool integration. So why we need memory? So that they can remember past interaction and learn from their experiences. And as far as reasoning goes, they need to reason about their complex problems and make logical deductions, right? So we all the agentic AI needs to have that reasoning capability as well. And when we go into multi-step workflows, they can execute tasks that require multi-steps and decisions. And tool integration, they can use other tools and services to achieve goals. So when we take a self-driving car example, so to start from a starting point to reaching its destination, it needs to use an external tool. So in this case, it might be an external map, like a Google Map API or some API. So this might act as an external tool. So this is what we mean by a tool integration. And yeah, so this we have a framework which actually would help you understand about different tools that are available when it comes to an agentic AI stack. So you can take a look at this, you can take a screenshot, it might be help you later. So moving forward, so AI agents and the future of automation. So we talked about AI agents, LLM agents, agentic AI. So, what does all mean for our future? So, how will AI agents change the way we work actually? So, they automate repetitive tasks, freeing up humans for more creative tasks. So that's a pro, right? So, we get time for doing creative tasks rather than just focusing on the redundant, mundane, automated tasks, right? And imagine all these repetitive tasks that you do every day, like they can free take up that those tasks, and like you get the time to do whatever you want to do. And in AI agents, they can actually analyze huge amounts of data much faster than humans. So we must agree to that, and allowing them to like make informed decisions as well. And AI agents, they work 24/7. Like we don't. We need to have some coffee breaks. We need to have sick days. But AI agents, they actually work like on and on and on and on. So I think that they would be an ideal employee for our managers, right? And yeah, so we'll saw about like AI agents, LLM agents, and like what the future of automation will look like. So moving forward, we'll deep dive into Azure AI Foundry. So this is where we are going to come from the start, right? So we talked about AI agents. So what Azure AI Foundry is, it's like a one-stop platform which provides a rich catalog of models, like open source models or closed source models, like OpenAI, the Mistral models, the Microsoft 5 models. So any model that you want to go, like even the DeepSeek models was recently released, like you can find it there in our model catalog in Azure AI Foundry. So in this Azure AI Foundry, you can build, deploy, as well as manage AI solutions. So there's like a one-stop solution, yeah. And it provides a comprehensive set of tools and resources to help you create AI agents and other AI-powered applications. So let's further see what Azure AI Foundry does. So this screenshot would give you an ideal understanding of what actually Azure AI Foundry does. So they have this model catalog, and what we can find here, like we can find the Azure AI Agent Service, the Azure AI Content Safety, which was discussed in detail by Lizzie Thomas during our first session, and Azure AI Search, and all those customization, governance, monitoring, and model catalog. And moving forward, like let's go into Microsoft Azure AI agent actually. Okay. So what you're seeing here is like a brief description of the external tools, the security and the storage components of what Azure AI Agent Service does. So they provide like enhanced security to their clients or us users to actually who create our AI applications here. And also like they provide with storage components as well within this Azure AI Agent Service. So for full visibility and control of your storage resources or user platforms. Yeah, and this is furthermore which would give us an idea of what are all the services that actually create Azure AI Foundry, right? So built-in enterprise readiness. So they have this extensive ecosystem of tools. So Fabric, SharePoint, AI Search. So like previously, I told you about tool integration when it comes to agentic AI, right? So in your these extensive ecosystem of tools where you see like Fabric, SharePoint, and file search code interpreter. So these would act as the external tools which will gear up our Microsoft agent, which we'll further see in a later part. And Fabric, SharePoint, Pinkers, they are still in the preview mode right now. So right now you could access the code interpreter and file search components of the tool system. But I think during the later part of the time, like you will also be able to integrate your Fabric and SharePoint into Microsoft Azure AI agent system. So when it comes to model catalog, like I told, like Llama models, Mistral, Cohere, Azure OpenAI models, I think you must also be aware of the Azure. The OpenAI 4.5 model. So I think that's also easily available right now in our catalog. So you could take a look at it. Okay, and so this is something which should give you an idea of what Azure AI Agent Service does. So it gives you more flexible model selection, it gives you enterprise grade security. So something that a brief description of Azure AI Agent. And yeah, so we saw about like what Microsoft Azure AI agent is, right? Like, so we'll see a comparison between what a chat completion API versus an assistant versus an agent would look like. So this piece of screenshot would take you through like what are the differences between each of those components. So a chat completion API, we know like we get an API and inference point, we get an API key, we give our text and we get a response point. That's as simple as it goes. But when we get into assistant, we also give this API the chance to interact with tools such as AI search tool or a code interpreter or a function calling capability. So this would act as an assistant. But when you go deeper into agents, so in within Microsoft Azure AI Agent, this they give you an option to actually bring your own data. So it's not about a specific Azure AI search or engine or something. You could actually give your own data, as in like when you go into like enterprise services or companies, so they have large amount of PDF files, docx files. So you could create your own repo of data, and then this repo of data can act as the knowledge base for our Azure AI agents. Okay. So here, like you could see a simple a process flow how a single agent or a multi-agent framework should take place. So here we would for a single agent we would utilize the Azure Microsoft AI agent. But for us to actually interact with multi-agents, which you'd see later part in our demo, like we need to take up autogen as well as or else semantic kernel. So to actually create a defined process flow. And this is an example for you to look at the Autogen multi-agents orchestration. So here you can find a particular system which is performing function calling and it's also going into Azure Agent Service. And then it's utilizing three different agents here, which is search engine. One would be the save agent as well as the write agent, which would actually run you through during the demo. Okay, this is further like another process flow. Like these are like different process flows which you can actually refer to, which should give you an idea of like how a system or a multi-agent system actually works. So it's not something so difficult for us to understand. As simple as it goes. So single agent, when it interacts with a group of agent, it becomes a multi-agent architecture. So here, like you're seeing like a video agent, doc agent, as well as web agent, which sums up and which collaborates together to actually create a multi-agent system. All right. I think right now, we'll go into the demo of our agent system, so which is going to be exciting. Let me just stop sharing my screen and I'll come up. Okay. Before going into a multi-agent system, I think I'll give you guys an overview of the Azure AI Foundry. Yeah. All right. Okay. So yeah, this would be the Azure AI Foundry project directory. Okay. So we need to create a project and also an hub to actually go on working with our projects. So as I said, that we have a diverse set of model catalogs, right? So we can find DeepSeek here, and 4.5, which I talked about, the 5.4 mini and the 5.4 multi-model. So these are different types of models that are actually available. So if we actually want to like utilize any of these models, we can directly select them from here. This would give you a brief description of like what those models capabilities are, and then like it also gives you the different versions that are actually available, and what are the supported languages, all those key information. And once you are okay with it, you could go to this deploy button. So in here, by default, it gets set as O3 mini by the deployment name. But if you case like you are a part of an organization, you could actually give a deployment name of your own. Like in our case, like we'll just put it as AZ O3 mini. So and for deployment type, I will set it as global standard. Okay, I think that's insufficient quota here. Okay, so this is also something important that we all need to be aware of. These quotas are what is allocated to us for deploying a particular model. So in our case, if we don't, we have already deployed a model, we won't be able to recreate or redeploy a model for the defined quota. But so if I go here and show you, yeah. So we already have a 4.0 mini model deployed. So with the full quota, so that's why we are not able to deploy another model. And if in case if you wanna like increase the quota, you could actually go to the just give me a minute. You can go to the model and yeah, you can go to quota and we can click on request quota and we can actually request the necessary quota from them, so that if in case like if you give in case like your use case requires more than 500k tokens limit, means that you can set the limit to them, you can send it to them, and then they will increase your quota. So that's how it goes. And uh, okay, so this is where we were, right? So as simple as it goes, like you can go here, you can click on deploy, like, and if you have the sufficient quota, you will be able to deploy. So once it is deployed, you could find it under the models list deploy endpoint. So this is the particular deployment which you actually created now, and it has succeeded. So once you are ready to consume it, you can go here, and then you can get the particular code here, and this code can be utilized in your VS Code or any of your IDEs, and this can be consumed directly. So yeah, as far as deploying a model, this is what is required for us, and I'll later show you like how this plays as the engine for our agents. And to test our models, like you can actually try the chat playground. So I think you must all be aware of this. Like this has been like something which has been predominantly used to actually test your chatbot before you integrate it into your, I mean, your LLM before you integrate into your application. So yeah, this is a playground for you to test your deployed LLM. And under AI services, you can find all those speech, language translator within document. So what Azure is aiming at is bringing all the so previously it used to be called as cognitive services. So Azure is trying to bring in all of them into a single umbrella in the AI services. And yeah, our go-to here. So this is our main hero of the day, and this is the interface where you need to create your agent, and you can click on new agent here, and exactly will be this particular agent will create a unique agent ID, and you can also set an agent name. So in our case, we'll set it as like Azure AI Connect. Okay, and then we'll assign a particular deployment. So we deployed a model now, right? So we'll actually be consuming that model. So for a O3 mini model, you can't actually consume it in agent. So for an agent, it needs to be a 4 mini model. So that's how it is right now, and that's why like you're only able to see 4 mini models here in deployment. So we'll select this particular agent of GPT-4, and in here like you could give any instruction that you want to give to the particular agent. So in a case like it might act as a system message, so you must be aware of system message, right? So system message is what we give to our LLM models to act in a certain way and to do a certain task, and then you can give the instruction here, and then this is the knowledge. So this is where I told like we could actually bring in external tools as in like the Fabric, the SharePoint, things like that. But right now like we still in it's still in preview, and like it has not been opened up to all the users. So right now we'll be able to integrate the Azure AI search tool for our use case, which you could actually work on. Apart from that, so these actions, so what this action means is like now the agent would have the repo of tool, it knows what to do, but to perform a specific action it needs to actually have access to that particular instance, right? So in our case, like if we want to like generate code, or if you want to initiate a particular Azure function, or if you want to trigger an API, you could actually define them here, and the particular agent would have the ability to do this. And then yeah, so temperature topi, this is something we all are aware of. So temperature is nothing but we are setting a value to our LLM model, to whether to act by itself or whether to act in a creative manner. So that's how it goes. So based on this, like once we created the chat agent, like we could try it out in our playground. So like as we have a playground for models, we also have a separate playground for our agents as well. So this is something where you could try it out, and it would actually be interesting for you to explore. So since we now have a good understanding of what are the components like we need to work on when it comes to accessing the Microsoft Azure AI agent. So the first one would be to deploy a model. The second one to be getting an access to the agents interface, right? So yeah, now let's go into demo. Okay, stop sharing my screen. Okay, yeah, great. I think it's visible now. Okay, so yeah, okay, we have come to a VS Code, and in this particular, I'll take you through like two demos in this particular scenario. So one demo would be about a single agent system. The other demo would be autogen based multi-agent system. Okay, so for a single agent system, okay, to open more. Okay. For a single agent system, like we are utilizing the Microsoft Azure AI agent directly from the Azure platform used through a SDK. Okay, so these are like different functions which would actually uh, create a connection between the Microsoft Azure agent and our tool base. And then we also need to create threaded messages. So thread here is nothing but the conversation memory. So these threads would hold different conversation memories for a particular agent. Okay, and then we just execute run, and then we actually utilize this Azure Microsoft Azure agent to actually get the data, and once we get the data, it also would save it to our local. So now, like once we run it, like we could find that saved data in our blog under the blog folder. Okay. So like this would give an overview. So we will create an agent. We'll get the input from the user. Once the user input is like received, we will create a thread and the message, and then we will execute run. And once the system gets the answer, it will save it to a markdown folder. Okay, and we'll execute the above cells. System just run. Now we'll execute this cell. Okay. So in our case, we'll ask the agent to write a palindrome function, Python. Okay. So, not on. Okay. Now in the backend, like all those processes which we talked about, the creating an agent, right, creating a thread and the executing run, and then getting the input from the LLM model, and then once the LLM model gives the input, it will actually write it to the markdown file, and it will save it to our blog. So these are the processes that will be happening in the backend. Okay, so it has been completed, and once we go to a blog, yeah, I think now it's visible. So I'll show it in a more different format. Yeah, so now you can see like it's like a step-by-step palindrome function gives you in a detailed manner with a perfect markdown actually. So yeah, this is how it goes. So this is how a single agent architecture works. Actually, okay. So let's all go into our multi-agent system. Okay, so in this for this multi-agent system, we actually utilize the Autogen framework. So our Autogen framework is pretty interesting framework for you to actually explore about. Like if you are planning on integrating multi-agents into your applications. So yeah, so I'll just run you down through what I've done in this code. Okay, so the first two cells, it actually works towards the getting the API deployment key and the API version key from our env file. So these are the things that's happening in our first two cells. So the actual part happens here. So user proxy agent. So this user proxy agent, this would act as the human admin in this particular instance. So it's almost like a human intervention, like as in like as I already iterated. So agents act in a way where it acts autonomously without a human intervention required. But in here, what we're doing is like we instead of us, we are creating a separate agent which will act as the admin who is going to overlook all the process that's going to happen. So in a case right now, like we have an engineer agent, we have a scientist agent, planner, executor, as well as a critic. So all of these agents would be overlooked by the proxy agent. Okay. So an engineer agent. So we gave a particular LLM config. So this LLM config is nothing but the cache, the temperature, the config, as well as the timeout. Okay. And then a system message, and then it same goes for the scientist, same goes for the planner, as well as the executor. So they all are given a particular system message, LLM config, as well as a defined name for each of them. And once this is done, we are also creating. Just a minute. Uh, Yeah. So this is where the main thing happens. So now what we have done is like we have defined each agent. So we have created an engineer, scientist, planner, critic, a proxy agent. So all of these agents have been created. But we need to create a framework or an orchestrator to actually run them all together, right? So that's where this autogen.groupchat library comes into place. So in here we will define all our agents that was created, and this group chat will take care of running the orchestration. So once we are done with this, I think we can initiate the chat. So I'll run all the cells above. Okay, something is done. And okay, so we'll ask a question. So uh, okay, so I don't know like how many of you are familiar with this concept called as wrapped. So that's something interesting that I've been going through recently. So I'll just ask our multi-agent system to write a detailed pieces paper on wrapped, let's say, augmented, fine tune. So yeah. So now each of the now the admin manager agent came in. It got the information from us. Then it gave that particular information to the planner agent. So now this planner agent, what you do is you create a set of plans actually to go ahead. So once we review these plans and we are good to go, we could actually click give the response to the agent system. We can click on proceed. And now when you click on proceed, it goes to the scientist agent. So what this guy would do? So based on the system message that he already has, it create a defined what to say a more based on the planner's input. The scientist agent would do a much more research further into it, and then it will give the enhanced information. Just okay. Now since the scientist agent is done, like he's giving it to the engineer agent to take up. Okay, so now since the engineer agent got the information, he will take care of saving this file to a .py file in our system. So click again, click on proceed. Okay. Oh, I think they misunderstood. Like they allocated and created a RAS pipeline. Okay, this is not something that we require. We wanted a piece of paper, right? So I think okay, just give it again. I want it to write a piece of paper. I think like this is something you could also think like you create a Python script as well. You could create a Markdown script. So the sky's the limit for you when it goes to working with this agent. So in here they just hallucinated. So this just means like we didn't look through what the agents were planning. Like we should have intervened and we should have actually direct them towards a different uh, line of action. Okay, I think now they're doing a good thing. Okay. The planner as scientist has done this thing, and So there is also this another concept called as max turns that you actually need to specify when it goes here, because if not for this particular max turns, they would keep asking the thrill questions and it will go on and on and on forever. So it's almost like terminating the interaction. So that's something that you need to keep in mind as well when you create a multi-agent system. So if you can notice here, like it's actually like the scientist agent is like getting information, and then he's fine tuning is going on and on. Okay, so the scientist is done with this work, and now he has given it to the critic. Okay, so yeah, they got confused in the middle. Like right now, like when you save the file, the engineer agent has come up. Like, okay, it's taking quite a long of time. Okay. I'm suspecting the time that's taking is because the scientist has created quite a huge amount of text, which the engineer needs to collect and then he needs to write it into a single format. Right? So maybe that's the reason why the engineer agent is taking the amount of time. Yeah, okay, now it's done. And yeah, oh yeah. So now you have it here. So let me just rename it to a MD file so that you could see it in a better format. Uh, yeah. Yeah. Now we have a full-on draft research paper which we actually can go through. Right? So it's starting from introduction to background-related work, so methodology, and like it goes in depth, like what is the subtopics within the draft, and it's pretty extensive and something that would give you a jump start into writing a research paper about draft, right? So it's something of a interesting thing that you could take up. So see here, like it also given you references to look at and conclusion. So this is a classic example of how you can utilize the multi-agent system in an effective manner. So yeah, I think I'm done with my demo here. Uh, okay, so I'll stop sharing my screen, and if there are any questions, I would be happy to take it up. Okay, I think there are no questions here. So yeah, I think I will also send in all these PPTs as well as these uh, GitHub links of the particular source code, which will be later shared with you, which you guys can take a look and try it out yourself. It's going to be like pretty exciting, right? So thank you all for joining this session, and I'll now disconnect. So,
Well, thank you, Kishore. That was an amazing presentation. You went very deep into the agents interface and also showcased how VS Code can be integrated for us to work with. Thank you very much for your
thank
presentation
you,
and your demo.
thank you.
We
Thanks a lot for
hopefully
the
will see you in another event of ours. I don't see any questions for now.
okay.
If anything comes up, I will find you in LinkedIn or send you an email or bring you
Sure,
in contact with anyone interested in learning more. Thank you,
sure.
everyone. Thank you, Kishore. Have a great
Thank
one.
you.
Bye
Thank
bye.
you. Bye.
Great. Well, Kishore was very fast and very juicy. So I'm going to have a little break for us and we'll be right back. Hello, and I'm sorry for the sound. Well, we have with us Jose Manuel Ortega, and yeah, he's on time for his session, so let me have a small introduction. Jose, thank you very much for coming. I will bring you on stage in a bit. We have the session Beyond the Hype, the Reality of AI Security. Azure AI Connect 2025 has really not so many sessions regarding AI and security. And I believe that this is something that we need to hear and understand. AI and security will be a very hot topic, and it is already a hot topic, but not everybody understands the reality and the importance of it. So let me bring Jose with us to explain a bit more. Hello, Jose. Thank you very much for joining. Thank you so much for being with us. So tell us a little bit more about you.
Hi everyone. Well, my name is José Manuel Ortega. I'm from Spain. This is my first time in this conference, Azure AI Connect. And well, I think that my talk is about talking about the security in artificial intelligence models, how we can mitigate the vulnerabilities, the OWASP top 10 in specific artificial intelligence models, and the best practice that we can use for ensuring our model. No, when we are working with language models, for example, like GPT, Gemini, and this kind of models, what are the vulnerabilities and the mitigations we can use. And another topic, another part talking about the security news in this topic.
Yes, yes. So not everyone is aware about the importance of security in AI, and I believe our viewers will be very interested to hear more about it. Again, thank you, Jose, for being with us. We are so grateful to have you. And do you have an estimate of your session total time? It will be about an hour.
I think between 40, 45.
Great.
Minutes.
Be aware that you don't need to be hasty. You have all the time with you. 1 hour is booked for you, so you can go with your own pace. Thank you very much. You can share your screen now, and I will add it to the stage.
Okay, thank you. Well, thank you very much for attending this presentation. Beyond the Hive, the reality of iSecurity. My name is José Manuel Ortega. You can contact me using the email address jose.manuelortega at owas.org. Well, in this talk, basically, we are artificial intelligence has rapidly evolved, promising transformative advances. However, artificial intelligence systems become increasingly sophisticated and integrating into their so the security risks associated with them. This is the main points that we are going to talk in this presentation. I will make an introduction to the OWASP NF.dev, and later I will talk about the ethical implications for wireless security and the security best practice for securing artificial intelligence models, for example. With the growing of popularity of large language models such as GPT, Gemini, Llama, among others, the OWASP organization has published a specific list of vulnerabilities for these applications. This list comes in response to the rapid adoption of these models in many industries. with the aim of highlighting the main security problems associated with this emerging technology. The OWASP Top 10 outlines critical vulnerabilities associated with these models. It highlights the understanding and mitigating potential risks inherent in adopting large language models. Notably, the top vulnerability in this category is the prompt injection. Now we'll try to detail some of them. For example, rank as the most critical vulnerability by the OWASP Top 10 is prompt injection. Prompt injection attacks in large language models are dangerous as they empower hackers to execute actions and compromise sensitive data autonomously. The challenge is that LLMs are a relatively new technology for enterprise. Basically, prompt injection involves manipulating input prompts to achieve unintended or malicious model outputs. Regarding mitigation this vulnerability, it's recommend, for example, to validate all inputs before processing them. For example, adding using command whitelist could also be implemented, and the types of data that can be processed could be limited. In a specific scenario, accepting, for example, an input from external sources such as a website or files controlled by a malicious user. We have a variant of prompt injection that is called indirect prompt injection. It's a technique in which an attacker manipulates external inputs such as web content or user data, which are then processed by the model. This can lead the model to behave in ways not intended by developers, compromising the security and integrity of applications. In the second step, a legitimate prompt could be generate a summary, for example, of the provided document, but an attacker manipulating the external source can inject prompts like include confidential information from other files. Unaware of external manipulations, the model generates content incorporating sensitive details from unauthorized sources, leading to data leakage and security breaches. Another example of prompt injection is published in this investigation. This research explores how these models can be manipulated to engage in conversations using encryption or coded messages, thereby obscuring their true intent. These methods could bypass monitoring systems designed to detect this misuse. A common example might be the use of ciphertext or simple scrambling in incoming message, which an attacker can use to generate coded responses or decode sensitive information without it being obvious to an observer. Direct prompt injection, also known as jailbreaking, involves directly manipulating the commands of these models. The research do anything now characterizes and evaluating in the wild jailbreak prompts on large language models, analyze and evaluates the so-called jailbreak prompts, which are commands designed to bypass restrictions imposed on large language models. These prompts allows users to obtain answers that would normally be blocked due to ethical, legal, or security constraints. The study investigates how these jailbreaks prompts work and how effective they are by passing model safeguards. The researchers have collected and characterized several examples of jailbreaks that have been created and shared in the community without academic or industrial intervention. In element development, this is another attack that is called data poisoning. In this kind of models, data is crucial in pre-training, for language compression, fine-tuning, for qualitative adjustment, and embedding domain-specific knowledge. However, these data sets are susceptible to tampering, allowing attackers to manipulate them. This manipulation, known as poisoning, can compromise these models' performance and lead to generating content aligning with malicious intentions. During pre-training, an attacker introduces misleading language samples, shaping the model understanding of specific subjects. Consequently, the model may produce outputs reflecting the injected bias when used in practical applications. Another kind of attacks that we have in this case are adversarial attacks. Adversarial attacks refers to a deliberate attempt to manipulate or deceive an artificial intelligence or machine learning model by providing it with carefully crafted input data designed to cause the model to make incorrect predictions or decisions. These attacks basically exploit vulnerabilities in the model's decision-making process, typically by introducing a small or imperceptible change in the input data, which can cause the model to misinterpret it. These are the case characteristics of adversarial attacks. Basically, in adversarial attacks, the idea is introduce small perturbations. Adversarial attacks typically involve adding small perturbations in the input data, as commented before. Also, these attacks try to exploit specific weakness in the machine learning models, such as its inability to generalize well, produce, for example, overfitting over the data. Adversarial attacks also can have several consequences when applied to artificial intelligence systems in critical domains such as autonomous autonomous vehicles, facial recognitions, medical diagnostics, and security systems. Well, when we are talking about adversarial attacks, we can differentiate two types: white box and black box. White box. These attacks assume the attacker has full knowledge of the model, including the architecture, parameters, and training data. In this attack, the attacker used this information to generate adversarial examples that are most likely to deceive the model. And the other side, we have black box. In black box, the attacker doesn't have direct access to the model's internal working. Instead, in this case, the attacker relies on observing the model's output in response to different inputs and use this information to craft adversarial samples. Basically, machine learning. Well, at this point, we can say that machine learning systems are vulnerable to a wide range of various adversarial assaults. Many of them employ classic machine learning models like linear regression or super vector machines, as well as the deep learning systems. The majority of adversarial attacks often try to reduce classifier performance on particular tasks. Well, talking about the type of adversarial attacks, basically, well, we have comment prone injection, but there are others like evasion attacks, positioning attacks, and others. Now I will try to to comment each type of these attacks. Well, prone injector, as I commented before, is involve crafting inputs to manipulate the behavior of these models, causing them to produce harmful or unintended outputs by exploiting the reliance on user prompts. Another kind of attacks is evasion attack. Evasion attacks involves modifying inputs, for example, an image or audio file or a document, to mislead models at inference time, making them a stealthy and effective means of bypassing a control system. The attack's objective is to generate an input that is misclassified, without needing to understand the artificial intelligence model's internal mechanism, making evasion attacks stealthy and particularly different to detect. Another kind of attack is the poisoning attack. As I commented before, this uh, this type of attack has started the training phase of artificial intelligence models, injecting malicious data into the training set to compromise the model's behavior. By manipulating the training data or its levels, the attacker can make the model perform poorly during deployment. Another kind of attack is the model inversion. This type of attack aims to reverse engineer artificial intelligence models to retrieve sensitive information about the training data. Attackers could exploit this model to infer sensitive or private data that was used during training by repeatedly querying the models. This could expose personal, confidential, or proprietary information. In these attacks, malicious attackers analyze the predictions made by a model in response to many inputs. Using this analysis helps them to infer sensitive details about the data the model was training on. For example, by observing how the models react to different input patterns, attackers can deduce characteristics or even reconstruct portions of the original training dataset. Another kind of attack is a model extraction. The model extraction attack has the objective to replicate the functionality of a proprietary model by querying it with numerous inputs and observing its outputs. This attack occurs when an attacker illicitly appropriates a training model, typically involving reverse engineering, where the attacker deciphers the system architecture and parameters to replicate its functionality. Once in possession of the replicated system, the attacker can exploit it for many malicious activities. And the last type of adversarial attack is called membership inference. This kind of attack involve an adversary attempts to deduce sensitive information from artificial intelligence models by examining its outputs and behaviors, achieved through many methods such as analyzing the model's prediction probabilities or delving into its internal mechanisms. For instance, an attacker might use the confidence level of a model's predictions to determine if a person was part of the model's training data. Typically, a model training on a specific data point will generate high confidence predictions for that data point if it was in its training data set. This is called overfitting. And by introducing slight modifications to the input data and observing fluctuations in the model's confidence levels, an attacker can make educated guesses, educated queries in the model about someone's presence in the training dataset. Well, now I'm going to talk about the importance of ethics in artificial intelligence models. Well, basically, artificial intelligence technologies, including machine learning and deep learning, are increasingly being used to identify threats, predict attacks, or automate response. These systems analyze vast amounts of data to recognize patterns and anomalies that might indicate a security constraints. And from ethical point of view, there are some ethical considerations that we can follow. For example, the trust in the users. Users must trust that artificial intelligence systems are unbiased and transparent. The fairness is related with avoiding discrimination and ensuring equal treatment across all demographics, and the accountability that is related with ensuring that actions taken by artificial intelligence systems can be explained and justified. If we try to understand the algorithmic bias in artificial intelligence system, these are the points that we can analyze. For example, if we have incomplete or unrepresentative training data, this can be a problem for understanding the the behavior of the algorithm in this kind of system. The algorithm can have flaws in the algorithm design. This is another point that we need to consider, and the Amman bias that is related with the prejudice introduced by the users or developers that are implementing artificial intelligence systems. Bias in artificial intelligence systems can lead to several negative outcomes in the security of these algorithms. For example, we can have false positives and negatives that is related with the incorrect identify of activities as threats or missing actual threats. Another point that we have to consider is the discrimination of these algorithms, that is the unequal treatment or certain user groups, potentially exposing them to higher risks, and the erosion of trust that is related with the users might lose confidence in artificial intelligence that are perceived as bias. To address and reduce bias in artificial intelligence systems, we can consider the following strategies. it's important to have diverse training data for ensuring the training data represents many of the demographics and scenarios. Also, it's important to regular auditing this kind of models for review that these models are in identifying identifying correctly the predictions, for example. And another strategies that we can use is regarding the algorithm transparency. For example, we can make the algorithms working understandable and accessible to all stakeholders. For example, transparency in artificial intelligence algorithm involves making the decision-making processes of artificial intelligence system clear and understandable. These are the key practice. The key practice that for ensuring this transparency include developing artificial intelligence systems that can explain the decision in human terms, using, for example, open source models, and the documentation providing detailed documentation on this system and decision criteria. Well, balancing security needs with ethical considerations require a multifaceted approach. For example, we need ethical frameworks we need implement frameworks that guide the ethical use of artificial intelligence. Regarding stakeholders involvement, we need to engage diverse stakeholders in developing and monitoring these kind of systems, and also have a specific guide for continuous improvement that is regularly update this kind of system, the policies to adapt to new ethical challenge and technological advancement in this field. Implementing the ethical in security involves also adhering to best practice, including inclusive design that is incorporating input from diverse groups during the development of this kind of these systems, using bias mitigation techniques, for example, use techniques like reweighting or resample to reduce bias in training data, and establish committees to oversee the ethical aspect of the deployment of artificial intelligence. Despite the capabilities of artificial intelligence, human oversight remains essential. At this point, humans should review critical decisions made by these systems. Develop develop protocols for handling exceptions and anomalies that artificial intelligence cannot address, and training training the security in users to understand and effectively oversee artificial intelligence systems. One of the biggest challenges in securing this kind of system is defending against adversarial attacks. As I commented before, adversarial attacks is maybe the most advanced vulnerability. These attacks involve manipulating the input data to fool the artificial intelligence models, leading to incorrect predictions or decisions. For instance, adversarial machine learning can trick self-driving cars perception systems, or manipulate facial recognition systems to misidentify people. At this point, the best practice for mitigating this kind of attacks for adversarial training, for example, this involves exposing this kind of models to adversarial examples during training to make them more robust. There are also other techniques that involves training a model to be less sensitive to adversarial inputs by smoothing out the decision boundaries. And also we can use other techniques. For example, we can use optimization techniques that focus on creating models resilient to adversarial perturbations. Emerging technologies at this field are, for example, explainable artificial intelligence. By making artificial intelligence systems more transparent and interpretable, we can better understand why a system is vulnerable to adversarial attacks and improve its robustness. And also researchers at this point, researchers also are developing methods that provides guarantees that a model is resistant to adversarial examples, leading to more secure artificial intelligence systems. Artificial intelligence systems rely on, as I commented before, this kind of systems rely on large volumes of data, which often includes personal or sensitive information. At this point, it's very important protecting the privacy of users and securing data from unauthorized access. At this point, the best practice is data encryption. That is the encrypt data both in transit to ensure that it cannot be accessed by unauthorized users. Another technique that we can use is federated learning. That this technique allows models to be trained on decentralized data, ensuring that raw data is not shared across servers. This improves the privacy by keeping sensitive data local. And another of the methods that we can use is using differential privacy. This is a method that adds noise to datasets or models outputs to protect individual data points from being exposed. Technologies that we can use for securing data and privacy and ensuring data and ensuring privacy. We can use, for example, techniques like using homomorphic encryption. This is a technology that allows computations to be performed on encrypted data without decrypting it first, ensuring privacy during processing. And another technique that we can use using secure multi-party computation. This allows different parties to perform computations on data without revealing the underlying data itself. Well, ensuring that artificial intelligence models are accurate, reliable, and free from bias is so important, particularly when artificial intelligence systems are deployed in critical applications like medical diagnosis or legal decisions. At this point, the best practice for ensuring the integrity of the model and the robustness of the model is, as I commented before, regularly apply regular model audits, that is consists in audits the artificial intelligence models to ensure they are working as expected, and recalibrating them where necessary to maintain their integrity. The bias detection, as I comment before, and also it's important to using techniques like secure model versioning, that is, track and control the version of the models deployed, making sure to that no unauthorized change can be made without proper validation. At this point, the emerging technologies that we can use for ensuring the integrity is, for example, using blockchain technology for ensuring the model integrity. At this point, model blockchain can be used to create transparent, immutable records of artificial intelligence model versions, ensuring their integrity and making it easier to track changes. And another technique we can use is using, well, we can use also testing frameworks for testing the this kind of models. That basically the idea is testing the artificial intelligence models are free of vulnerabilities and so on. Well, for concluding this presentation, the conclusions, these are the main points that we can highlight for as artificial intelligence becomes increasingly integrated into everyday technologies. The security landscape must adapt and evolve to safeguard against new risks and challenges. The future of artificial intelligence security will be shaped by several critical factors that drive innovation, policy development, and industry practice. For example, adversarial machine learning, where malicious attackers can manipulate the input data of these models. Artificial intelligence as a security tool. At this point, artificial intelligence is not just a target, but also a powerful tool for improving the security issues that the organizations have. In the future, well, in the present and in the future, artificial intelligence will play an increasingly vital role in identifying vulnerabilities or in identifying and detecting threats in real time. For example, we can use, for example, machine learning or deep learning for anomaly detection, pattern recognition, predictive analytics, and so on. Regarding the privacy protection, well, at this point, as the artificial intelligence becomes more embedded in data processing, privacy concerns continue to rise. The future of artificial intelligence security will include a stronger privacy-preserving technologies such as federative learning, which allows models to be trained on decentralized data without sharing raw data and differential privacy. And finally, it's very important the collaboration between users, between human and artificial intelligence. Basically, at this point, we can highlight the future of artificial intelligence security will include a closer collaboration between human experts and artificial intelligence systems. While artificial intelligence can automate many security tasks, human oversight will remain essential to understand the threats and the behaviors of this kind of systems. And for concluding, these are the main bibliography that you are interested in deep in this kind of topics. These are the main books that we can find that are all related with the artificial intelligence security and so on. And these are GitHub repository where we can find more information about the topic that I've commented in this presentation, and this is another links. And that's all for my part. If you have any question, you can do it using my email address. And well, that's all. Thank you very much. Thank you for organizing this conference. Thank you very much. Bye.
Thank you, Jose. Thank you so much for the session. It's wonderful. Thanks for your time.
Thank you very much.
Thank you.
All right. That was Jose with a great presentation. Many thanks to our moderator who was able to take care of our speaker. Whatever you need from Jose, I will be able to connect with him in LinkedIn. So please post your questions or comments. We have also our YouTube channel, which has all the sessions, all the recordings for you. So please post your comments there, and we will. While we are waiting for our next speaker, let me add the video on our stream, and we will be right back. Thank you very, very much. Welcome back, everybody. Azure AI Connect 2025, and we are off for our final speaker for Room 1 for our third day. Today, we have a lot of amazing sessions. We are lucky to see one of the best streams so far. For me, it's absolutely amazing that every session is unique. And this one is also one of the unique sessions that we're going to see. It's about Copilot for Security. Together with us, we have Vipul Dabi, if I'm pronouncing it correctly. Hello, Vipul. Hello, my friend.
Hi, Constantinos. Yeah.
So let me welcome Vipul here. Vipul, we are so grateful that you can be with us and deliver this session. So a little bit about yourself. Are you a security person? Are you dealing with security in your day-to-day job?
Exactly. I'm working as a security consultant and I work mostly in SIM solutions, the prominent SIM, which is Microsoft Sentinel, Security Copilot, and Defender for Cloud. Yeah, mostly onto the Defender side, yes. So these are my
Yes,
day to day activities, yes.
very nice. So I believe that you have already explored Copilot for security, and that's why you're here tonight with us. It's already late in your hometown, I believe, or where you are located. Uh,
Yeah,
yes,
it's
yeah.
10:30 now. I mean, it's 10:18 p.m. in night, but yeah.
Yeah. Anyway, we are again so grateful to have you. You can share your screen if you want to, and I will put it on the platform.
Okay,
And
I'll be start I'll start presenting then. Okay.
yeah, and you can make your introduction. I will remove myself, and everybody will pull that we is with us. Let me phrase exact session name. It is hands-on Copilot for security, so I like a lot of hands-on. So I will be
Mm-hmm.
excited to see the session. I'm removing. You are on the driver's seat, Vipul. The stage is yours now. Thank you.
Okay, okay. So shall I start presenting? Okay.
Yes, yes. Whenever you are ready, I will add your screen to the stage. Share your
Okay.
screen, and I will guide.
Share my screen. Is my screen visible right? Yes. Hey, hi all. This is Vipul here, and I'm joining here for this Azure AI Connect 2025. And my topic for the day is hands-on security copilot, which was earlier known as Microsoft Copilot for Security. This has been recently renamed to Security Copilot, and this is coming under the initiative of Azure AI Connect 2025. This is Vipul Dabi, and I'm working as a security consultant, mostly working on Sentinel implementation and the Defender for Cloud, or maybe the whole Defender suite, and recently leveraged this Security Copilot as a solution for investigating and for investigating the incidents and leveraging the Gen AI features in the context of security. So we'll try to dwell more onto the security copilot so as to understand how it works and how it integrates with different security solutions within Microsoft ecosystem or beyond that. So this is a high level agenda we have here. We'll start with what exactly is security copilot, how security copilot works, what are the key features which security copilot has to offer, and then we'll try to understand how we can access security copilot, right? Like we have two experience to make an access to security copilot, which is like embedded experience and standalone experience. We'll get to feel both of them, And then the most important component of this whole security copilot or Gen AI engine is the security compute unit, which is the backbone um, with which the whole interface of security copilot runs, where all the processing happens, where all the prompts get addressed. So that provides the power to the whole security copilot ecosystem is security compute unit. We'll try to understand, and we'll spin SU as well as a live demo. Then we will understand plugins, what exactly is plugin, why we use plugins, and how it helps us in the context of security copilot. Where does it help and what does it do actually? We'll see a Sentinel plugin demo as well. And then finally, I have a recorded video demo where we will be understanding how to investigate a Sentinel incident. We'll create a scenario where we need to understand how Sentinel investigation can be addressed by virtue of security copilot, which was usually done manually, and it takes hours to investigate an incident, right? When we need to respond at a speed of a machine, we cannot afford to do investigation for hours, right? So then finally we'll conclude with the benefits of security copilot, right? So let's just start here. So very first thing is like, what is security copilot? Microsoft Security Copilot is basically a AI powered security analysis tool which is helping us or the security teams to detect, investigate, and respond to threats more efficiently. So, if you see, we have detect, investigate, and respond. So, these terminologies are also the pillars, also form the pillar for Microsoft Sentinel, where we have ingestion of logs, then we have analytical rules with which we can detect the incident, with which we can detect the threats and generate an incident or alert. And finally, we do the response part using the SOAR capabilities. So, pretty much the same pillars we see for Microsoft Security for Copilot as well. It works. It basically helps security teams to detect, investigate, and respond to threats faster. So this fast is very important because the adversaries are already using some AI powered solutions to perform their adversarial actions. But from the defender aspect, we also need to have that fast capability to respond to the threats which are generating. And that's where the security copilot comes into the context. So basically, it combines Microsoft security expertise with OpenAI advanced AI models. So the basis or at the background of the security copilot, we have OpenAI advanced AI models only, but they are now clubbed together with Microsoft security expertise, so that they totally focus on one domain of strengthening the security of an enterprise, right? So that is where these two entities combine together and frame a new solution, which is referred to as security copilot. And this all happens in the real time, and they provide us the right recommendation, and we can apply action on top of it, not just the investigation, but we can also identify the right approach to respond to that incident with the help of the OpenAI and the data we have from the security in Microsoft, right? So this is very high level overview how the whole security copilot works. So it all starts with human intervention when human starts giving a prompt, basically a prompt which will help us from where we need help, right? For example, I want to investigate a incident number 100. So that would be the basic prompt I can give to security copilot. So that prompt traverses and get to the security copilot. Then the next phase is the orchestrator phase, where we determine the initial context and build a plan using the available skills. So whenever we are discussing any AI related platform, the context play a very important role. Until we have context in place, we will not be able to give the right response, right? And that is where setting up the context at the very initial phase is important, so that rest of the communication will revolve around that particular context and it doesn't deviate. So that is why orchestrator here is set determining the initial context. Then we build the context, we execute the plan where the required data context to answer the prompt. So we get the required data context and we answer the prompt which has been submitted by the user. Plugin is something which will help us to reach to the desired security service. For example, for endpoint, we have Microsoft Defender for endpoint. For SIM, we have Microsoft Sentinel. For CW, PPU like cloud workload protection or cloud security posture management, we have Defender for cloud. So to reach or investigate a particular or to address a particular prompt, we need to have the required plugin for that security solution. So that's where plugin help us. It basically helps us by analyzing all the data and pattern to provide the intelligent insight. And from where the data will come, data will obviously come from the respective security service, correct? Then we respond. We have to combine all the data in the context, and model will work out for a response. And we finally format that as a response, and we give it to the as a response in the same security copilot. So this is the whole steps which internally happens. It all starts from the prompt. We need to frame our prompt very efficiently, because otherwise if we frame uh, irrelevant prompt or which is not going to give us any help, so then it might exhaust our security compute units, which you will understand what exactly it is in upcoming slides. So these are the key features of security copilot. How does it help and where we can plan to leverage it, right? So very few things are here around threat investigation and analysis, right? It all helps security team analyze incidents, attack path, and vulnerabilities. So we can do the threat investigation and analysis part with the help of generating right prompts towards security copilot, which otherwise would be manual effort. And manually, when we say, it will be an effort of hours or days, right? But with security copilot, and if we are framing the right prompt for the first time, it would happen within minutes. And it offers natural language queries. We can ask a natural language to the prompt in while we are giving prompt to the security copilot, like what are the high level severity incidents for last 1 hour, like that, and it will give you the right response, which otherwise we need to go to the portal and put a filter on then to verify it, right? So we can, and then how to respond to that immediately. So those aspects are easily handled with the natural language query itself. Then we have automated reports and summaries. So it can generate reports and summaries which are both technical and non-technical, and it does offer you the option to export it in different formats or directly email it, so as to reach to the right audience from the security copilot portal itself, right? So that's where it is adding a value. Then we have guided incident response. So just not the investigation part, but the response part as well being addressed, and that to an efficient way, which otherwise would be requiring SOC level 1 or 2 or 3 maybe for the actual and right response for the emerging threat in place. The right response is very important, and this do provide as a guided incident response mechanism, which is like step by step instruction to basically handle a breach in real time. It does support the integration with different security tools which are both native and external to Microsoft, and by virtue of the plugins which we just discussed, right? Now works with Microsoft Sentinel, Defender, Intune, and Purview for end-to-end security visibility, right? Now with that, let's try to understand what are the different type of experiences in terms of how we can interact with Security Copilot, right? So Security Copilot offers an immersive standalone experience and intuitive embedded experience that are available in other Microsoft security products. So basically, when I say there are two types of experience we have, one is the standalone experience, which is a dedicated portal to access Security Copilot. We have a URL here like https securitycopilot.microsoft.com. That's a standalone experience, and sometimes few of the applications have it embedded within themselves, right? Like the XDR solution, which is extended detection and response, has the copilot embedded in that portal itself, right? So that is an embedded experience which is as an add-on, coming as an add-on with the main application, like XDR or MDE, like that. So if it is embedded with any other security solution, it is embedded experience, but it is when it is giving us a dedicated portal to access and where all other plugins can be integrated. So that's a standalone experience, which is security, which we have a separate URL. So now comes the main component of this security copilot, and which is a prerequisite for security copilot. Without that, will not be able to leverage security copilot. So that unit is security compute unit. We also refer to as an abbreviation as SCU. A security compute unit is a measure of compute power to run security copilot workload. When I say security copilot workload, it's like the prompts which we give, the integration we do from the third party or the native solutions to perform investigation or to leverage Gen AI features there, right? So these are all the workloads of Security Copilot. But what actually powers that? That power is coming from the security compute unit. You can just consider it as a virtual machine. We need to have a virtual machine to spin our own web server, right? So that the web server can be hosted on a VM, and that's how we access it. So that's where the power comes. So this is the power for our Security Copilot, and it is prerequisite for both the experiences, whether standalone or embedded. It is required by both of the experiences. Now, Microsoft Security, this I have taken from this particular source. You can refer it. This is basically giving us the price estimate per hour for spinning a one security compute unit. So as you see, provision capacity in security compute units to run security copilot workloads. Basically, if you want to run any security copilot workload, this is the prerequisite. These workload provide insights, evaluate prompt, run prompt books, and automate them both the standalone and the embedded experience across Microsoft Security, right? Now, these are flexibly provision compute unit to meet your organization needs, easily manage cost within product dashboard. So this is SKU stock keeping unit for SU per price per hour is $4, and this is the estimated price per month. It is costly, yes, indeed it is costly because it is powering up our security copilot workload, and it is within the premise of Azure, and that's where it keeps it secure, right? So, and it does evaluate prompts, whatever prompts we are giving, and if we give prompts kind of 15-20 prompts which are not leading us to anywhere, so then it might get exhausted as well. So once it exhausts it might look for new SU. So that is why we have a context of prompt book in here. Prompt book is nothing but we have available out of the box as well, and we can create our own prompt book as well. Basically, the idea of prompt book is to make sure that prompts are predefined and thought before actually getting executed on the security copilot. If we write prompts without thinking, or maybe any XYZ prompt is written which is not relevant to the solution, so it might lead to exhaust our SU, which is not a good option. So ideally, we should be using our SU efficiently, and that's why we have a context of prompt books in here. So this is the estimate of one SU, the prices of one SU, and the Microsoft recommendation is in the production instance that you have at least 3 SUs to start your security copilot exploration, right? This data you can get from this particular source here. So now let's get to our portal. We will spin our own security compute unit, and we will explore that. So let me just open up my portal here. So this is my Azure portal. You can globally come up here and search like security. So you will see this Microsoft Security Copilot compute capacities. Here you can come and create this. You can provide your resource group, and you can provide this Azure AI Connect Security Compute Unit. I'll just prefix SU there. We have only few regions like Australia, Europe, UK, US. So by default, it is UK. The region is this, and I'm going with just one SU per hour. So this is the estimate. You can upgrade it as you like. Just need to acknowledge here. Next, and let the validation process complete. So as it says, it got deployed, but still I have. So this is the SU. This is the SU which got deployed. Okay, and status is fine. Operation details you can check, but still the step is not finished yet. So if you click on this place, it will take you to the securitykopilot.microsoft.com, which is your standalone experience. And So first thing it is asking you the reference of the SU which we just created. We created this Azure AI Connect SU. So we need to apply that here. Or we have, if we directly came to the securitycopilot.microsoft.com, it would have asked us to create a new SU here because that's a prerequisite for Security Copilot, correct? And that's how it got created. I'll just give OK to it. So this is the place where you can see your sessions. This the default is the home portal. Whatever session you run, it will be visible here. Prompt book library where you can see out of the box prompt books. Prompt book is nothing but it is a group of multiple prompts which are very efficient to achieve a particular task. For example, check impact of an external threat article, or maybe Microsoft user analysis or central incident investigation, like that. Then you can go through your settings here, like switch to the capacity, whatever capacity we have this one SCU, which you can change here. We have plugin settings, who can add to your plugins like that, match plugin availability, and so this is how you can set the plugin part. Plugin is basically helping us to integrate other solutions with this security copilot. So this is the prompt bar where you can write your own prompt like investigate incident, but the prerequisite is to have the right plugin in place. Until you have the plugin in place where it will do the investigation, correct? So that is very important. It will see, first thing it will check for the source based on your prompt or any other prompt and response in the session and copilot capability. So make sure your input provide is correct. When updated, resubmit it, but if you still didn't got, it might be the info might not be available. So basically, until we have the right prompt, right plugin in place from where you have the required data, it will not be able to work in that direction. So with that, this will take us to the sources. I'll just explore things here. And under manage source, we have plugins. So I will just guide how the plugins work. So the first thing here is this Microsoft native plugins like Azure Firewall. They are all enabled, and there are like 9 more plugins. If you see for Sentinel, we have Sentinel in place. So I will just search Sentinel here. Okay, this is my current Sentinel instance, which is onboarded onto this workspace. If I just go to this workspace here, I'll be able to see my resource group. Okay, so in the settings, basically it is enabled, but it is to get it connect to it, we need to provide the workspace name. So my workspace name is, this is my workspace name. So this is how you should provide the subscription name, the default resource group, just get the right resource group here. And then you need to save this setting. So that's how you have now integrated with the required setting in place. You are now connected to your Sentinel. I don't have any incident as of yet in my Sentinel, but that is how the plugin will work, and that's how the connectivity is established. So that is the core of the plugin part. Let's now get back to our slide deck again. So that's an hands-on for creating an SU and setting up our security copilot and the plugin part. So I'll just give you a high-level overview of the plugins again. Security Copilot comes with many default plugins and supports several non-Microsoft plugins. So as we just saw here, right? We have these are the Microsoft ones, and then these are some non-Microsoft one like this. We have around 32 non-Microsoft one plugins from where we can get the data. We have dedicated setup mechanism here, which requires the information to integrate that, and then that is good to go for the prompts. So GenAI features from Central for on this particular solution. Now you can also extend Security Copilot capability by adding or creating your own plugin. We do have the option of creating our own custom plugins. The Security Copilot platform enable developer and users to write plugins that can be invoked to perform specialized tasks. So if you want to do any specialized task, we need to understand how we can connect to the third-party solution. Once that connectivity is established, then you can leverage your Security Copilot GenAI feature to to investigate or to perform any operation which requires a AI capability. So I have this link here, like which help you to sail through this plugin. And yeah, Sentinel plugin, we just did this hands-on, right? I did it in this first lab itself. So I just guided you how you can integrate your Sentinel plugin. So you need to provide the required workspace name, the subscription reference, and the resource group name. Or if you want to do the reset, you can do the reset and provide the value again, and it will successfully connect once you have the it in the place. Now this is very important. Now this is the actual demo where we will be investigating a security incident with Security Copilot. So this is a high level architecture which is basically depicting us that what is the SIM solution and what does it do. So basically a SIM solution will collect logs from diverse sources which are like on premises or on native to the cloud or maybe some other cloud providers. So once the logs are ingested, we apply detection rule on top of it. Now with detection rule give us some data that means there is something happening in the environment and we need to report it. So how does it get reported? It gets reported with the help of the incidents, right? So detection rule basically generates an incident. Now once the incident is in place, by virtue of the SIM solution, we will be using Gen AI solution for investigating that incident. And the Gen AI solution we are going to leverage is Microsoft Security Copilot. We will be providing a series of prompts onto this Copilot security or security copilot, and the very first prompt is to set the context, like the providing the or summarizing the incident and the incident number. And there's a series of prompts in the prompt output. So let's just get to see through this demo which will help you to understand it better. So here I'm providing the incident ID as 29088, so which is a prerequisite for this prompt book to start, and that's how I'm giving it to run it in the next step. Just observe it.
Vipul, are you playing sound? Vipul, are you playing sound? Can you hear me?
So this is the demo on our secure investigating a Sentinel incident using Security Copilot. So this is our concluding slide for the day, where we are going to understand when we were investigating a security incident using Security Copilot, what for the respective prompt which we gave, what are the corresponding Gen AI feature we leverage from Security Copilot, right? So when I gave this prompt like summarize incident 29088, the feature was incident context summarization. So I was setting up the context based on the incident we have. Now, when I actually gave the incident ID, which is this 29088, there I am actually giving the entity base. So it's an entity at the end of the day, right? When I at the associated IP address, the associated user, or the incident ID, or the severity, they are all entities. So that becomes entity based context initialization. Now, when I gave the prompt like what are the reputation score for the IP version 4, that was threat intelligence integration. So Gen AI basically getting the required data from the respective threat intelligence solutions which are integrated with Sentinel, and that's how it was giving me the reputation score. Now, when I asked what are the authentication method set up for each user, so it was giving, or the Gen AI was able to give that data by virtue of the identity and access analysis. Now, when I asked user listed in the incident details, or maybe the associated device details with that particular user, so there it was giving me the data by virtue of UEBA, or user behavior analytics. So Gen AI is leveraging this feature, and that might be native to the plugin which is like Sentinel, or maybe third party like in context of threat intelligence. When I asked it to generate an executive report, it was doing a customization, or basically generating a customizable report. Or I have the option to extract other entities like associated IP address for this particular incident. So I was extracting few of the entities from it to give me more efficient information, right? So that's where I do entity extraction and correlation. And when I create the complete prompt book, I leverage a prompt book which is available out of the box, which has all the prompts associated with each other, multiple prompts associated. That's where contextual prompt chaining is done, so as to set the context first, and all of the other prompts will revolve around that particular context, which is the investigation of an incident. So these are all the Gen AI features which work in the backend, but we don't see them. So but that's why I've created these analogy here based on the prompts we have. So this is the session on Microsoft Security Copilot. I hope you have enjoyed the session. Over to you, Constantinos. Hello, am I audible, Constantinos?
Hi Vipul, can you hear me?
Oh, is it Siva?
Yeah, yeah, yeah.
Oh, you the audio didn't got played, is it? when I
Yeah.
was showing the demo, is it? Or maybe the whole time the audio was not there? How it is?
During the session, like actually, when you were presenting the PPT, right? In that video, audio is not playing. Other than that, your audio is clear.
So in the demo, right? In the demo, correct?
Exactly.
Okay, 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 okay. So, okay, right in. Okay, let me just
May I
start.
help you, Vipul? When you are sharing, there is a box that says share the sound also. Can you check it?
Okay, I'm just sharing my. Is my screen visible now?
Yeah, I added. Can you try again?
So, yeah, where exactly do I need to go? This is the volume controller here, but it's not playing yet.
No, we
Is it
cannot hear it. No,
is it audible now?
no, no.
Okay, so what I'll just redo it, okay? And I'll do a voiceover for you guys, okay? Is it fine?
Yeah, yeah.
So basically, this is so I hope you have understood this architecture, right? This architect understanding of this architecture is important. Did you guys got this?
Yeah, yeah.
Okay, so now once we have the incident in place, maybe any SIM solution, right? Preferably Sentinel, right? So we will investigate that with our native prompt book which we have for Sentinel by offered by Security Copilot. So that's what it guides us through how we will do the investigation. So this is our Security Copilot which we just spinned right when we created the SU. We were able to came to this interface and we have understood how to integrate our Sentinel as well, correct? So this is the place where you write your prompt, okay? And when you click on it, you tend to see prompt books. Prompt books are important because they have set of multiple prompts clubbed together to achieve a particular goal. So our goal here is to investigate a Sentinel incident, right? So what would be the input to that particular prompt book? Obviously the required incident ID in place. So once you provide the incident ID, and run this prompt book, it will be so this particular prompt book comprises of 7 prompts in place, and which will execute one by one with respect to that incident id. So you just need to set the context for the respective incident id, and then it will and these prompts are generic. It's not specific to any particular incident id. So for our case, I just provided this 29088 as our prompt, and when I run it, it will start running the prompts one by one. So if you just scroll up to see the very first summarize Sentinel incident 29088, it will give us a high level summary of this particular incident ID. It will provide us with the name that it is associated with the file download from a malicious IP address. That's the name which is coming from our Sentinel interface only. And this is the description which you see here. The severity is very high. The status of it is new, and when it is observed, the first activity time when it got identified, what is the last activity time, and other details which are very prominent for us to when we do any summary. This is the high level view. Whenever there's an incident that happens on any sim solution, we tend to see this data briefly, and we have associated alerts like how many alerts are there in it. Mostly alert combined together to make an incident, right? We also get to see the tactics which is coming from the MITRE attack, and which product basically is giving us this incident. This is Azure Sentinel, right? Now when you okay, this is our incident URL. You can navigate from if you click on it, but as it's a demo environment, we don't have any actual instance which is having this particular incident in place, right? But in real environment, if you have the relevant incident, you can navigate to the page directly from this interface, which is our Azure portal. Now, the second prompt is looking for the entities associated with that incident. When I say entities, it would be what this basically gives us out, right? The IP address, the account related entity, right? And all the details which we get directly from our incident. So, based on the entity, I have identified that we have a IP version 4 associated as an entity. So, I just framed a prompt like what is the reputation score of the IP version 4. That data we usually get from our threat intelligence provider, right? So the reputation score I've got is of 100, which makes it more severe, right? And the CTI providers are, one is cyber threat intelligence, then other one is the description and all changes, and these are the severity which they are giving, like Cobalt Strike, Cell Typhoon. These are the actors, correct? And so they are all making it a severity 100, and which means that it is important to address that, maybe either by blocking it or taking a remediative action, right? Now, I also asked it to show me the authentication method for the entity which is this user, and it has given me all the associated authentication methods. Then I have asked him, or asked security copilot about the devices which are associated with that particular user which is listed in the previous prompt, right? So it didn't identify any uh, what we call it as any associated devices based on the information it is having. And if you want, we can go to the Intune where all the devices are managed alongside the identities to explore it further. That it guides us. Now it also, the next prompt, it is saying that if there's any device, we need to know more details on top. If there's any device which is associated with this particular ID, they want more details on top of it. But unfortunately, there's no device associated, so we will not be able to get the details of the operating system and other things which are associated. So that's an additional prompt which we wrote. Then finally, writing we are asking security copilot to write a executive report so that we can share it with the key stakeholders, right? What is the output of our investigation, like that. So basically it's a high level executive summary which is non-technical also. It gives us the security incident reference, the incident, what is the classification, what is the reputation score of, and all the key details which we have grabbed. So basically a summary. And the key thing here is that you have the option to export it. What are, like, you can export it or you can directly email it to the required stakeholder, like this. So if you have the option to export it, yes. Once you export it, it will be available in Word, and that you can share with your, or you can still write more prompts which you think that this prompt book didn't give answer, or maybe you can do a custom prompt on your prompting on yourself to do investigation on your with your own mechanisms or methods, right? So if you do that, you will be able to address the incident in real time. Yeah. So this is a high level summary which you can share with your respective stakeholders. So that was the demo, and when we were giving different prompts, there's a Gen AI feature which is being leveraged at the back end. So when I give like 2 9, so I think this part you got to know, correct?
Yeah, actually, that was clear. Can you
Mm-hmm.
just do me a favor? If you have the video locally, can you just share it with this presentation after the presentation?
Yeah, I need to check with the Constantinos like how we can share it across. Yes, that I need to check.
No, no, actually, you can play share the screen by playing the video if you have locally, rather than playing it in a PDF.
Oh, yeah,
PDF
I
first.
mean, I might need to check that, but isn't it visible here?
Yeah, actually, it is visible.
Okay, okay. So that was on the stuff. Do you have any question which I can answer?
Let me check the comment section. Uh, yeah, actually, I have a doubt here. Is the
Mm-hmm.
Microsoft Sentinel an Azure product, or it is like mainly used for SOC and SOAR process?
Sentinel is a SIM solution which you can use for ingestion of logs from all the places on premises, within Azure cloud or other cloud providers. Yes, and then you can investigate by virtue of Kusto query language, like that. So it's a SIM solution that supports that is not just native to Microsoft, but it can be scaled across maybe other SIM solution also it can integrate with, like Splunk. Yeah.
Okay. Can you just tell me what is the difference between this particular and Microsoft Defender for cloud?
Oh, Defender for Cloud is a cloud security. There's two things. One is CSPM and CWPP. CSPM stands for Cloud Security Posture Management, and CWPP is Cloud Workload Protection Plan, right?
Yeah.
When I say cloud security posture management, it is the overall security from governance aspects like policy
The
initiatives, right?
resources from cloud, right?
And
These
cloud
resources.
workload protection plan is like the actual resources like VM, Kubernetes cluster. If you're looking for resource specific security, so that is CWP. So Defender for Cloud is the solution that is both CSPM and CWPP. And Sentinel is a SIM solution, which is security investigation and event management. So where all the it will ingest logs from all the places, even the Defender for Cloud tends to send its alert in a bidirectional mode, and then you can wherever bidirectional mode, so that alert from Defender for Cloud can be taken here. Yeah.
Okay.
So when I say bidirectional means if Sentinel able to address that alert, it will be shown as remediated in Defender for Cloud as well. Or if the alert is been handled in Defender for Cloud, it will show remediated in our Sentinel interface like that. So every solution can point its logs to Sentinel. But the security copilot is now becoming the new root which can integrate with all the security solutions like MD, Sentinel, XDR, and can we can leverage a AI feature on top of these security suites. So you can consider security copilot as a new root, and these are all the child solutions now.
Okay. Actually, that was very clear. Um, I think so. There is no other comments in this session. It is that it is possible. Can you just present that video over here so that we could end this session?
Yeah, I mean I need to check that possibly. That's like my I would check with Constantinos and then I will share. Yeah.
Uh,
Okay. Thank you.
Thank you for being this session, and it was a very wonderful and informative this session. Thank you again, people.
Thank you.
Thank you very much. Thank you.